Understanding the Physics of Flight by Mina and Dea Pavlovska. Lift is what allows airplanes to rise into the air, and it happens thanks to a few key concepts. The shape and design of the wings are made to help the plane lift off while also cutting down on drag, which helps save fuel. According to Newton's third law, when the wing pushes air downward, the air pushes back up on the wing with an equal and opposite force, helping the plane go up. The way the air moves over the wings also plays a part, because the air moves faster over the top of the wing, creating lower pressure, while the slower air below the wing creates a higher pressure. This difference in pressure pushes the wing up, creating the lift that makes flight possible.
Thrust is the force that propels airplanes forward, generated by engines to overcome drag. Factors like altitude and temperature affect engine performance and thrust output. There are two main types of thrust: jet engines, which propel air backwards at high speeds, and propeller engines, which convert rotational energy into forward motion. Thrust operates based on Newton's third law. As the engines push air backwards, an equal and opposite force pushes the plane forward, allowing it to move through the air.
Drag is the force that slows down an airplane, and it comes in two main types. Parasite drag is caused by the shape of the plane and increases as the plane goes faster. This happens because air resistance pushes against the plane's surfaces, creating friction. The smoother the plane's shape, the less parasite drag it creates. Induced drag, on the other hand, is related to the lift generated by the wings and becomes more noticeable at slower speeds. When the plane generates lift, the airflow around the wings creates additional drag. Managing both types of drag is important because more drag means the plane uses more fuel and is limited in speed. Reducing drag helps improve fuel efficiency and performance, allowing the plane to fly faster and smoother while using less energy. By carefully designing the plane to minimize drag, we can make flights more efficient and reduce the environmental impact of flying.
Weight is the force of gravity acting on the airplane, and it plays a crucial role in flight. It consists of several components: empty weight, which is the weight of the plane without cargo or fuel; payload, which includes passengers and cargo; and fuel weight, the weight of the fuel on board. Heavier planes require more lift to stay in the air, which in turn increases fuel consumption and can limit the aircraft's speed and climb performance. Properly managing and balancing weight is essential for safe and efficient flights, as it ensures stability and optimal performance throughout the journey.
Control surfaces are the movable parts on an airplane that allow the pilot to control its movements during flight. There are three main types of control surfaces. First, ailerons, found on the wings, control the plane's roll, which means they help tilt the plane from side to side. This is important for turning the plane smoothly. Elevators, found on the tail, control the plane's pitch, or up or down movement. They allow the plane to climb or descend, helping the pilot adjust the altitude. Rudders, also found on the tail, control the plane's yaw, which means left to right movement. The rudder, it helps steer the plane and keeps it on course. These control surfaces work together to make sure the airplane is stable and responds to the pilot's commands. They are essential for maneuverability, whether the plane is making turns, climbing, or adjusting direction. Without these surfaces, it would be much harder to control the plane, making them very important for safe and smooth flying.
A stall is a condition where the airplane's wings lose lift, making it unable to sustain flight. Stalls occur when the angle of attack, the angle between the wing and the oncoming airflow, exceeds a critical limit, causing the airflow to separate from the wing surface. Low speed can also contribute to stalls because it reduces the lift generated by wings. The effects of a stall are serious, leading to loss of control and altitude, and in some cases, a downward plunge. To recover from a stall, the pilot must lower the angle of attack to restore smooth airflow over the wings and increase speed by adding thrust or gently descending to regain lift.